Welcome to GW Prime Live. Your way is here. Data-driven approach towards the modern day problem such as climate change can lead to actionable and informed conservation strategies. From tracking wildlife population, disaster management, mapping carbon emissions, and upkeeping the general health of the nature, geospatial data can be a bane. To discuss how data from varied sources can be collected and used strategically for the betterment of cities, citizens, and the environment, today at GW Prime Live, we have Mr. Amin Ra Mashakiri, who is the Director of AI and Data Strategies at the Bezos Earth Fund. He works to identify strategies and solutions that will help environmental justice organizations to use data to solve complex issues. Welcome, Mr. Amin.
Hi, nice to meet you. Thank you for having me.
Mr. Mann is a former White House Fellow and the Chief Technological Officer for the U.S. Office of Personnel Management in the Barack Obama administration. He has also served as the Urban Analytics Lead at Esri. So, my first question to you, Mr. Amin, will be environmental justice in an intriguing term. What do you encapsulate with that term, and what are the projects currently deployed to catalyze environmental justice from the Bezos Earth Foundation?
Yeah, so I think that's a big question, and there's a lot of ways to think about environmental justice, but specifically, you can think about it from the funding perspective, making sure that organizations that are focused on the ground implementation of solutions that have an impact on communities that have historically been left out of these types of solutions. And so you can think about environmental justice from the perspective of funding organizations working with those on the ground organizations. You can think about environmental justice as the action that these types of on the ground frontline organizations take to protect their communities. You can think about environmental justice as a wider group of environmental organizations focused on a clear set of values to make sure that as we transition to new energy infrastructures and frameworks, that no community is left out. And so there are many different ways to think about environmental justice. At the Bezos Earth Fund, specifically with respect to my role as the Director of AI and Data Strategies, we've implemented a few things. So one is we think that for environmental justice to have environmental justice organizations to be able to implement environmental justice, access to data that local data and detailed data is very important. So we funded the ability for a couple of environmental justice organizations to come together and work to build out what we refer to as the Environmental Impact Data Collaborative. And so that's organizations working together to surface important data, but then that's also working with academic institutions to build a platform to house that data. And so we have that data. If you go to eidc.org, you'll be able to get access to a lot of data that any environmental justice organization or anyone, quite frankly, can use to have an impact in many low-income, underserved communities.
Sir, can you please tell me about your time at the White House and the work you did there?
Yeah, I mean, that was wide-ranging, but I think that, as you mentioned, I was a White House fellow and then a political appointee during the Obama administration. And so, I have my, doctorate in computer science. And so at the time, we weren't really doing a good job in the federal government in terms of hiring for innovative tech positions. So when I was there, data science was the big buzz, right? Data scientists and hiring data scientists and people wanting to be data scientists. That was the big buzz. And so we didn't have a mechanism for identifying and then hiring good data scientists into the federal government in order to use data science to solve a lot of these sort of public challenges. So my job was essentially to help leadership across the United States federal government to think through the best mechanisms to deploy to hire top data scientists, top computer scientists, top technologists, if you will, into the federal government.
As we are on the topic of data, you previously mentioned that a good analytic solution is 80% about finding the right data. With petabytes of data being generated, be it from satellite or internet, what kind of analytics is required to sift through usable and relevant data, and how can AI help in the process?
Well, I think that's the answer, right? So the more data that you bring to the table, and we know more and more data is being created every second. But not only the more data, more complex data is being brought to the table. And what we found is that um, if you have, let's just use a nominal number, right? If you have 10 petabytes of data, and you do some sort of analytics analysis on that data, you're going to get some insight into what's going on. If we're talking about environmental justice. If you double the amount of data, you actually, quite frankly, don't get double the amount of insight, right? It's laws of diminishing returns at that point. You could triple, quadruple, 10x the amount of data. You're not going to get that much amount more of insight from that data because the analytics itself is limited in what it can find. That's the power of AI. The power of AI, generative AI, or what we refer to at the Bezos Earth Fund as modern AI. The power of modern AI says, as you double the amount of data, and we double the amount of accelerated compute, the amount of compute power, we can grow linearly the amount of insights and the capabilities that we're able to glean from this data. And so the more data, to answer your question directly, the more data we have access to by using AI to analyze and understand and train on and then make inference on that data, we'll be able to find linear levels of insight into that data.
And since we're on the topic of data, in the era of geofencing, where everything is being driven by personalized data, how can we apply principles to this data that are both robust and ethical, especially now with generative AI in the picture?
The short answer to that is that we've historically been in this space of exposing our data to large organizations, and large organizations managing our personal data, whether that's photos that we put online, whether that's content like YouTube videos or blogs, posts, and so on and so forth, and even research work. Organizations themselves function as these data repositories that store our data and then use it however they want. In this new world, and in order to be ethical, fair, and be able to manage that data in the right way, we need to start understanding how we as individuals can manage and have oversight over our own data and share with entities as we see fit, as opposed to just giving it to other entities to do what they want with it. So I think there has to be a more granular, you used the term geofencing in terms of identifying specific, not only areas, but even granular spaces. We have to be even more granular in terms of how we're storing and managing data down to the person.
On the same topic, I would like to further ask you that would you agree that this is that data integrity and ethical AI is a top-down approach, or will it be a bottom-up approach where people have to identify that their data is at risk, or do we need policies in place that can help identify people that your data is at risk?
So I think my personal opinion here is that it's got to be bottom up. It's got to start bottom up. And if we can start bottom up, we can build an understanding and an ecosystem that forces and that drives policy. So I'm not saying that policy isn't helpful here, but I'm saying that we need to drive policy. And then once we drive policy, then that bottom up approach where the ecosystem is built, the organizations, the individuals are driving this, then we can have an impact on the solutions that would exist within these organizations, which would ultimately be the top down. So we've got to start bottom up, have an impact on policy, which would then engage the top down entities to do their work. So I think it's all of the above. But if you look at the orchestration and the sequence of this, it has to start from the bottom up.
And I think nobody can answer this question better than you, as you've greatly worked at the New York City's data analytics department. From your experience, what were the benefits of solving problems with data, and what can be the learnings for cities in the third world countries?
In that instance, and what I believe is also the case where it's applied appropriately, where data is applied, data and analytics and AI is applied appropriately. What we were able to do was to partner with city agencies to help them think through 4 key things. How can they do their services faster, right? How can they do this work with scale? Because New York City is a big city, and it's really tough to think through. It's easy to think through how do you do something, implement some sort of service on a block or in a neighborhood, but how do you do that citywide? So speed, scale, and then we had to work with them to be more accurate and precise in their work, right? And because that's important in terms of providing services for residents. And so we work with them, we use data to help them meet those 4 criteria: speed, scale, accuracy, and precision. And I think data and analysis and AI, that's the key role of these capabilities.
Coming back to the topic of sustainability, now we're seeing urban heat island effect, a very common and reigniting issue that has been plaguing major cities worldwide and has been the talk of the town. What role can technology and data play in safeguarding our cities against these adverse effects?
So I think there's a couple of roles. Let's start with monitoring, right? So we have to know and understand what's happening and where, right? And so accurate data, accurate systems and platforms will allow for us, and an accurate analysis will allow for us to be precise and clear on what's happening where, all right? Then when you move from, monitoring to solving a problem, which is ultimately mitigating this problem, you can use data and analysis from a simulation standpoint. So if you built out, let's say, using a digital twin, using data for a digital twin, or some 3D map infrastructure, think through, well, if I placed green infrastructure, trees, parks, any number of architectural structures in these places, what impact will it have on these so-called urban heat islands, right? Because what you want to do is be accurate and precise in how you apply the mitigation. So you want to simulate that, and you say, well, if we put these things here, what's the impact? Then you say, okay, well, if we moved it around and we made these shifts. And so you would want data and analytics and AI would help you simulate solutions. And then for adaptation as well, right? You want to understand what are some things we can do, where can we apply sort of cooling centers so that we can manage the impacts of these urban heat islands. You would use geospatial data and location intelligence to help you identify those things. So monitoring, mitigation, and adaptation all have a role in pushing back against these urban heat island effects. But across all 3 of those, data and analytics will be the driver.
Very insightful, Ms. Raman. You've been very vocal about open data and accessible data. You also mentioned in your answer for environmental justice that making data accessible for communities that are not possibly getting the amount of data they require for better environmental practices. So, can you please talk more about the benefits of open data and the role of technology development and the society it provides?
Similar to open source, open data does a couple of things. One, it provides a baseline of understanding, right? It's the same thing we tend to say in social settings is that any argument, any debate has to always start with the same set of facts. You can't have two sets of facts and then expect to get to some solution with regards to a debate. And so what open data essentially says is, as a core baseline for solving any problem, we have to all be working from the same understanding, right? And so open data allows for that shared understanding. But then also, and I think this goes back to the conversation around environmental justice. Part of that conversation, especially on the data and analytics side, is making sure that we have people who are from these communities that are adversely affected by climate and nature change that haven't been engaged historically, that solutions have to come from these communities, right? And not only environmental solutions, but also the tech and AI solutions has to come from these communities that are affected. So meaning literally the students and the researchers and the schools that exist in these communities have to be stepping up to offer solutions. And the only way you can do that is if you have access to the data that everyone has access to. The top scientists at NASA has access to data that now these high school researchers in this one community has access to. And that's what open data does. It connects those pieces such that you can bring more people to the table to provide solutions.
Quoting the Bezos Earth Fund, solving climate change requires more than lowering emissions. Being the director of AI and data strategies, how can data aid towards a holistic climate positive action around the world?
Again, I think it's a combination of everything that we've talked about here, that understanding the problem leads to clearer solutions for solving the problem globally. And we know that these actions have to be taken in partnership with many organizations. One country, one organization is not going to solve this global issue. Many countries, all countries, many organizations are going to have to solve this. And so understanding, having a clear and consistent understanding of what is happening, and then being able to partner on how to solve that is important. And so shared technology and understanding is key here.
And lastly, what is the roadmap ahead for the Bezos Earth Fund?
Well, so I can tell you, I can speak intelligently around the roadmap for the AI program at the Bezos Earth Fund, and we just launched our $100 million grand challenge for climate and nature, AI for climate and nature. And so we're looking to work with and engage organizations globally who are thinking through how to use AI to solve climate and nature. And really, our key focus is on bringing together climate and nature organizations with AI organizations to solve these problems in this decisive decade.
Thank you so much, Mr. Amin. It was really nice talking to you.
Thank you. It was my pleasure. Thank you very much.
Thank you.
Take care.
Hello and welcome to the GW Bulletin, daily dose of geospatial news on GW Prime Live. I'm Jeffy Jacob, and here are the latest happenings. South Korea's SK Group announced that its chip manufacturer, SK Hynix, will invest approximately $75 billion by 2028 to enhance its chip business, with a particular focus on AI development. According to a report from Commercial Times, SK Group recently concluded a two-day strategy meeting, after which it announced a full-scale effort to develop the AI capability, putting more emphasis on areas such as high bandwidth memory, AI data centers, and AI voice assistants. SK Group further stated that 80% of the fund, that is $60 billion, will be dedicated to developing HBM. HBM is widely used in generative AI chipsets, and SK Hynix is currently the exclusive supplier of HBM3 chips to NVIDIA. Japan deployed an upgraded Earth observation satellite for disaster response and security after it was launched on a new flagship X3 rocket. The X3 rocket lifted off from the Tanegashima Space Center on a southwestern Japanese island and released its payload about 16 minutes later as planned, the Japanese Aerospace Exploration Agency or JAXA said during a live stream. The Advanced Land Observation Satellite, or ALOS-4, is tasked primarily with Earth observation and data collection for disaster response and map making. It's also capable of monitoring military activity such as missile launches with infrared sensor developed by the Defense Ministry. MTG-S1 is the first European sounding satellite in a geostationary orbit, which will bring a revolution for weather forecasting and climate monitoring in both Europe and Africa, and makes it possible for the first time to observe the full cycle of a convective storm from space. Its launch will ensure that national weather services can benefit from new and more accurate data to protect lives, properties, and infrastructure. As such, the EUMETSAT member states decided to award a launch service contract to SpaceX for the launch of the Meteosat third generation Sounder 1 satellite on a Falcon 9 rocket in 2025. A month after its launch, ESA's EarthCare satellite has provided the first image from its cloud profiling radar, an instrument developed by the Japan Aerospace Exploration Agency. Equipped with 4 advanced instruments, EarthCare is designed to explore the role clouds and aerosols play in Earth's atmospheric heating and cooling, enhancing the understanding of climate change. The initial image is split into 2 sections, the left part revealing the vertical concentration of cloud particles measured as radar reflectivity, indicating denser regions at the center with larger particles. The right part shows the fall speed of cloud particles with low values in the upper layer indicating suspended ice crystals and snowflakes, and higher values below indicating rain. The self-driving robotaxis developed by Amazon's daughter unit known as Zoox has started testing in Nevada, Austin, and Miami. This is one of the first deployments outside of its current test region in California. It confirmed that it is ramping things up a notch in our pursuit to provide the world with safe, comfortable robotaxi rides. The autonomous EVs can reach up to 120 km per hour, and Amazon paid $1.3 billion to acquire Zoox in 2020. Airbus has entered into a binding term sheet agreement with Spirit AeroSystems in relation to a potential acquisition of major activities related to Airbus, notably the production of A350's fuselage sections, A220 wings and mid-fuselage, as well as the A220 pylons. Airbus aims to ensure stability of supply for its commercial aircraft programs through a more sustainable way forward, both operationally and financially, for the various Airbus work packages that Spirit AeroSystems is responsible for today. The transaction would cover the acquisition of these activities. Airbus will be compensated by payment of $559 million from Spirit AeroSystems for a nominal consideration of $1, subject to adjustments including based on the final transaction perimeter. Datumate, a construction data analytics company, has announced a strategic partnership with Birdseye Aerial Drones, led by industry veteran Scott Painter. This alliance is set to transform surveying practices for engineering and construction firms worldwide. This partnership combines Datumate's innovative analytical technology with Beat's operational prowess, promising unmatched surveying solutions. Key benefits for clients include cost efficiency with streamlined operations to reduce surveying costs. Precision, as lower altitude flights provide higher detail and time saving, whereas drone surveys complete tasks 80% faster than traditional methods. French space agency CNES has selected a consortium led by Infinite Orbits with Telespazio France to conduct two satellite service missions in geostationary orbit. CNES ordered a life extension mission and an inspection mission, both funded by the French government under the France 2030 Economic Incentive Plan. Infinite Orbit said in a recent press release the first mission will use its Endurance vehicle, a 750 kg docking servicer. And Endurance will perform a docking on an active end-of-life commercial telecommunications satellite, providing station keeping for 5 years and managing its end-of-life disposal in the graveyard orbit. The second mission, a smaller 50 kg orbit guard servicer equipped with electric propulsion, will demonstrate a proximity inspection of Meteosat 8, a non-operational EUMETSAT satellite. Cube has partnered with Solid State Propulsion to integrate SSP's state-of-the-art pocket rocket vacuum arc thruster into its satellite platforms. The SSP Pocket Rocket, a compact and reliable electric plasma thruster, offers unparalleled performance in a remarkably small package, making it ideal for Cube's next-generation satellite missions. The partnership between Cube and SSP represents a significant step forward in commercializing advanced space propulsion systems. By leveraging SSP's innovative thruster technology and Cube's expertise in satellite design and deployment, both companies are poised to revolutionize the future of space travel and satellite operations, sparking excitement for the potential of this collaboration. And with that, we come to the end of this live bulletin. See you tomorrow with more news from the geospatial ecosystem around the world.